Hello everyone, today I'm going to go over lesson 8.3 where we're going to start to get into trigonometry, which is sort of what we've been doing, but when we talk about trigonometric ratios, that's what we're going to talk about today. So what is trigonometry? The definition for it is it's just the study of triangle measurement. And so we've been doing this when we use Pythagorean theorem or special right triangles in order to find missing side lengths. We'll be able to do that again today by using these trigonometric ratios. So these are the buttons on your calculators that say sin, cos, and tan. You might have wondered, like, what are those for? This is when we use them. The first one that we're going to see is sine, and that is defined as the ratio of the leg opposite the angle to the hypotenuse. So basically what that means is if we're looking at angle A, to find the sine of angle A, you just have to take the ratio, or in other words, like make a fraction out of the leg that's opposite the angle and the hypotenuse, which is this one, the one that's across from the right angle. So that would be A over C. If we're looking at angle B over here, the leg that's opposite it is B. So it's going to be B, and it's still the hypotenuse, so it's B over C. So that's sine. Now let's talk about cosine. It's almost the same, except now it is going to be the leg adjacent. And remember, we've seen this word before in geometry. The word adjacent just means like next to. And so if we're looking for the cosine of angle A, we want the leg that's next to that one. So it would be this side, B, over the hypotenuse. And the hypotenuse is still that side that's labeled C. On the other hand, if we want the cosine for angle B, we need to pick the leg that's next to it, which is going to be A. So A over C, since C is the hypotenuse. Lastly, we have tangent, and that is the ratio of the leg opposite the angle to the leg adjacent to the angle. So if we're going to look for the tangent of A, we want to, on the top, we want the side that's opposite it. So that would be side A. And then on the bottom, we want the side that's adjacent to it or touching it, which would be side B. If we want the tangent of angle B, then we pick first the side that's opposite to it. So that's going to be that lowercase b, and then the side that's adjacent to it, side by side or touching, would be that side that's lowercase a. So there's going to be a really easy shortcut in order to remember these definitions. So that way we can just use that shortcut whenever we are seeing problems like this. So it's basically an acronym that you have to remember. And it is SO, CA, TOA. And we use this because the sine, which the S, is the ratio of opposite over hypotenuse. So it's, if you can remember that, you know, okay, sine is opposite over hypotenuse. Then cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So if you memorize that, that should help you whenever you're doing this lesson and the homework. So let's start to find trigonometric ratios, and we want to write them as fractions in simplest form. So we're going to start by focusing on angle A, and let's find the sine of angle A. Well, since sine is opposite over hypotenuse, I'm going to pick the side that's opposite to it, so 5 over the hypotenuse, which is 13. So 5 over 13, if I could simplify that more, I would, but 5 over 13 is already in simplest form, so I don't need to simplify that. Now let's look for the cosine of angle A. So I want adjacent, which is going to be 12 over hypotenuse, so 12 over 13. And then lastly, I want the tangent. So that is opposite over adjacent, so the side opposite to it is 5, and the side adjacent to it is 12. Okay, so now let's look for these ratios, but for angle C. So now I want to find the sine of angle C. So what side is opposite that? It's the side that measures 12. And then over the hypotenuse. The hypotenuse is still 13. That one doesn't change. Cosine of C is going to be the adjacent side, which is 5 over the hypotenuse, so 5 over 13. And then the tangent of C is going to be opposite over adjacent. So we're going to do 12 over 5. So we found the ratios for all of those. Let's look at number 2. And this time we're going to start by focusing on W. So the thing that I want to find first, because I know that sine is opposite over hypotenuse, but I don't know what the hypotenuse is, right? So I do know that there's a way that I can find that because I know 2 of the legs. So if I can just use Pythagorean theorem here, 9 squared plus 12 squared equals, let's say, x squared, then I can use that to find out what the hypotenuse is. So 9 squared plus 12 squared, you can type that into your calculator quickly, and that's going to give you 225. And then to simplify this, you just take the square root of 225, and that gives you 15. So now I know that the hypotenuse of this triangle is 15, which means that now I can find the sine of angle W. It's going to be opposite over hypotenuse. So 12 over 15. This is one of those that I can simplify because the number 3 is divisible into both of these. So this is going to simplify to 4 over 5. If you want to just use the calculator to help you do the simplifying part, I can show you the method of doing that. Next is going to be the cosine for angle W. So that's adjacent 9 over hypotenuse, which is 15. So when we simplify this, this is going to give us 3 over 5. And then lastly, we have the tangent for this angle. That's going to be opposite over adjacent. So 12 over 9, and 3 goes into both of these. 12 divided by 3 is 4, and 9 divided by 3 is 3. So that simplifies to 4 over 3. Now let's focus on angle x. So if I want the sine of angle x, I need to pick the side that's opposite to it over the hypotenuse, which is 15. This is going to simplify to 3 over 5. Next, I want the cosine, so the side that's adjacent to it, over the hypotenuse, so 12 over 15. And again, this simplifies to 4 over 5. And then I will need to find the tangent, so that's opposite over adjacent. The side that's opposite to it is 9, and the leg that's adjacent to it is 12. So 9 over 12 would simplify to 3 over 4. And then let's look at number 3. I can tell that this time I'm missing this leg. So again, I'm going to need to use Pythagorean theorem to find out what that is. And hopefully this process you remember doing in 8.1. So I'm going to call this like x. So I'm going to say x squared plus 16 squared equals 34 squared. This time I'm missing a leg, so that's why my x goes on the left side. Well, if I simplify this, I'm going to end up with x squared, and then I'm going to subtract the 16 squared from the 34 squared, and when I do that, I'm going to get 900. And then I square root this. So x equals 30. So that's what my leg is over here. And now I'm going to find out what the trigonometric ratios are for angle L. So for angle L, the sine of that is going to be opposite over hypotenuse, so 30 over 34. if I were to simplify this, I notice that the number 2 goes into both of them. So 30 divided by 2 is 15, and 34 divided by 2 is 17. So that's that fraction in simplest form. Next, I'm going to find the cosine. So the leg that's adjacent to it is 16, and the hypotenuse is still 34. So I have 16 over 34. This would simplify to 8 over 17. And then I'm going to do the tangent. That's going to be opposite, so 30 over adjacent, 30 over 16. And this would simplify to 15 over 8. Next, I'm going to focus on the other acute angle, which is angle M. So to find the sine, I need to do opposite over hypotenuse. So 16 over 34, that's going to simplify to 8 over 17. Next is the cosine, so I need the adjacent leg, which is 30 over the hypotenuse. So 30 over 34, that simplifies to 15 over 17. And then lastly, I want to find the tangent of angle M. So that's going to be opposite over adjacent. 16 over 30 is what my tangent is. 16 over 30 simplifies to 8 over 15. Okay, so that's how you find out what the ratios are when you're given the side lengths and you're trying to find either the sine, cosine, or tangent for a certain angle. You just work it out using SOHCAHTOA. So let's go ahead and go on to the next page. And on this side, we're going to actually calculate what some of these unknown side lengths are using these trigonometric ratios. So this is an instance where we don't know all three of the side lengths, so we can use this thing, SOHCAHTOA, because we can basically set up an equation and then solve for our variable. It says solve for x, so that's what we're going to be doing on this page. So let's look at number 1. I know that this angle over on the right is 28 degrees, and the side that I'm trying to find is the leg opposite to my angle. And I also know that I'm starting with 19, and that's the hypotenuse. So if I'm given the side that's opposite and the hypotenuse, that means that I'm going to have to use sine as my trigonometric ratio. So I'm going to use the sine of my angle. So my angle measures 28 degrees, so I'm going to put sine of 28 and then set that equal to the sine of an angle is equal to opposite over adjacent. So since my opposite, I don't know, I'm going to put x. Oh, sorry, opposite over hypotenuse. So my hypotenuse is 19, and I'm going to put that there. So now what we're going to do is basically treat this like a proportion. So I'm going to put that thing on the left over 1, and then cross multiply, or do the butterfly method, whatever makes sense to you. So x times 1 is just x, and then I'm going to have to take 19 times the sine of 28. And this is where you're going to use your calculator, because we can't really figure out what the sine of 28 is without a calculator. An important thing when you're using that sine button on your calculator is to make sure your calculator is in degree mode. And I can show you guys how to make sure about that when we're in class. If you don't have a graphing calculator at home and you're just using Google, I'm pretty sure there's a way to make sure that you're in degrees on that Google calculator or whatever other calculator you're using. Basically, it can be either in degrees or radians. In this class, we're only going to use degrees. Radians is something that you use more when you get into pre-calc. So basically now we just type this into our calculator, and it's going to give us like a long decimal, and we want to round that to the nearest tenth, which means one spot after the decimal. So when we do that, we would end up with 8.9, and that's what this side length would measure, 8.9. So that's our answer there. Now let's look at number 2. So I know that I have have this angle that's 41 degrees, I have this leg, and that leg is adjacent to my angle. And then I have another leg that I'm looking for, and that is opposite to my angle. So if I have the opposite and the adjacent leg, I'm going to end up using tangent because of SOHCAHTOA. So I'm going to use the tangent of 41 and then set that equal to opposite over adjacent. My opposite leg is x and my adjacent leg is 32. So that's how I set that up. Now let's cross multiply to find out what my answer is for x. So I'm going to take 32 times the tangent of 41, and then when I do that, I am going to end up with 27.8, and that's my answer. Okay, so let's look at number 3. I am starting off with this 21 degree angle. I know the hypotenuse. The 26 is across from the right angle, so that's the hypotenuse. And I also know this side, x, is a leg, and because it's touching my angle, that makes it the adjacent leg. So if I have adjacent hypotenuse, that means that I need to use cosine in this instance. So I'm going to write out cosine of 21 and set that equal to adjacent over hypotenuse. So the side that's adjacent is just x, and the side that's adjacent measures 26. So I've set it up. Now let's just go ahead and solve for x. I'm going to cross multiply. X equals whatever 26 times cosine of 21 is. Go ahead and type that into your calculator. And what we end up with is 24.3. Next, let's look at number 4. So I'm starting with this 55 degrees. I have a leg that is adjacent to it. It's touching it. So that's an adjacent leg. And I want to find out what the leg that is that's opposite to it. So if I have opposite and adjacent, I need to use tangent again. So I'm going to write my equation. Tangent of 55 equals opposite over adjacent. So my opposite side is x, and my adjacent side is 8. Now I'm going to solve. So x would just be equal to whatever 8 times tangent of 55 is. And what that turns out to be when we round it is 11.4. Okay, so now let's look at 5. I have this angle that's 33 degrees. I know the side that's opposite to it, and I want to know what the hypotenuse is. So if I am having opposite and hypotenuse, I'm going to use sine because sine is opposite over hypotenuse. So let's write out the equation. Sine of 33 equals, well, my opposite side is 15, and the hypotenuse, I don't know what that is. So I'm just going to put x, and then I'm still going to use like a proportion to solve this by cross multiplying. So what I end up doing is taking x times sine of 33. X times sine of 33 equals, and then on the other side I have 15 times 1, which is just 15. And now to get x by itself, I need to divide so that I can cancel this out. So I can divide by sine of 33 on both sides. And then I can just go to my calculator. So type in 15 divided by sine of 33, and I can round that up to 27.5. Now let's look at 6. So I'm starting with this 43 degrees. I have this leg that's touching it, so that's an adjacent leg. And I want to know what the hypotenuse is. So the one that has adjacent and hypotenuse in it is cosine. So COHCAHTOA. So I'm going to say cosine of 43 equals 36 over x, because I don't know what the hypotenuse is. So to solve it's pretty similar to what we just did. I'm going to put that over 1, cross multiply. So x times cosine of 43 is what I have on one side, and then 36 times 1 is just 36. Now to get rid of this cosine 43, I need to divide by that on both sides, and then x will finally be by itself. 36 divided by cosine of 43 is going to be 49.2. Let's look at 7. So I am trying to find out what this leg is. That's an adjacent leg because it's touching my angle, 72 degrees. And I know what this leg is, the 25. That's the opposite leg. So if I have opposite and adjacent, I'm going to use tangent. So let's say tangent of 72 equals, well, opposite is 25, and the adjacent I don't know, so I'll just put an x there. Then let's go ahead and put this over 1 and cross multiply. So I have x times tangent of 72 equals 25. Now I can divide by this tangent of 72 to get x by itself. So x is equal to, when I type in 25 divided by tangent of 72, I end up with 8.1. So that's what that side measures. Let's look at number 8. So I want to find out what this side is. That's a leg, and because it's touching my 64 degrees, that's an adjacent leg. And then I have the side 11, because that's across from my right angle, that's the hypotenuse. So I want to use the one that takes into account adjacent and hypotenuse. That would be cosine. So cosine of 64 equals x over 11. So I'm going to cross multiply. X is equal to whatever 11 times cosine of 64 is. So when I type that into my calculator, I end up with 4.8, which is my answer there. There will be a few word problems where you're basically working with a diagram like the ones we've seen so far. You just have to create that diagram yourself by reading the problem. So number 9 says that Jake leaned a 12-foot ladder against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? So we basically have a ladder that's leaning against a house. So I know that ladder is 12 feet long, and I know that the angle that it creates is 68 degrees. I want to know how far from the base of the house did he place the ladder, so from here to here. So that's what I'm looking for. And if I think about what I have, the right angle is right here, so I have the hypotenuse, and this x is an adjacent leg to my 68 degrees. So if I have adjacent and hypotenuse, I'm going to use cosine of my 68 degrees. And then my adjacent leg is x, because I don't know what that is, and my hypotenuse is 12. So that's how I'm going to set that up. Let's cross multiply. X is equal to 12 times cosine of 68. So x equals, when I type that in, I end up with 4.5. And this is my answer, but since it's a word problem, I'm going to include my units, which would be feet. So this is the answer. And lastly, let's look at number 10. It says that a ramp is used to load suitcases on an airplane. If the cargo door is 7 feet from the ground and the angle formed by the end of the ramp and the ground is 25 degrees, how long is the ramp? So basically, I know that I have a cargo door 7 feet from the ground and there's a ramp. So let's draw the ramp. And the angle formed by the end of the ramp and the ground is 25 degrees. We want to know how long is the ramp. So that basically that. So what I have here is a side that's opposite, and I want to know what the hypotenuse is. So if I'm using opposite and hypotenuse, I'm going to use sine. So sine of 25 is equal to 7 over x. Then let's solve for this. So x times sine of 25 is equal to 7. Then to get x by itself, just divide by sine of 25. So x is equal to, when you type that into your calculator, you would get 16.6, and let's include our units, so feet. So this is our answer. All right, so that's it for the lesson on 8.3. Go ahead and make sure that you have the exit ticket done, the notes completed and turned in, as well as the homework on the next 2 pages of the packet.